Remember these dates, because within your lifetime, without ever leaving your backyard, you're going to watch the universe do things it has not done in 100 years, maybe 1,000. Right now, a rock the size of a skyscraper is falling toward Earth, and in a few short years, it will slip past us closer than our own satellites, close enough to see with the naked eye. In the middle of an ordinary afternoon, the sun is going to switch off and night will sweep across 3 continents in a matter of minutes. And out in the dark, 2 stars are spiraling into each other, on course to collide and set the sky on fire brightly enough to cast shadows on the ground. We tend to look up and see a still frozen picture, as if the cosmos had paused a long time ago and simply left it there. That is the great illusion. The night sky, it's not a photograph. It is a countdown, and almost every one of these is coming sooner than you think, and the very first is already overdue. So, let's walk the timeline from the closest to the most distant and see exactly what's coming for us. But the soonest of them all is not years away. It could happen tonight, or it may already have happened, and its light is still racing toward us across the dark. Look toward a small crowned-shaped constellation called Corona Borealis, and right now you will notice nothing unusual, just a faint curve of stars. But astronomers have been watching that exact patch of sky with held breath, because hidden inside it is a system on the verge of detonating. Its name is T Coronae Borealis, the blaze star, and it sits like a ticking time bomb roughly 3,000 light-years away. The setup is deadly simple. A dying, super-dense white dwarf is locked in a tight orbit with a bloated red giant, quietly stealing gas from its neighbor one thin layer at a time. That stolen hydrogen piles up on the dwarf's surface, heating and squeezing, until it crosses a razor's edge, and the whole surface erupts in a colossal thermonuclear blast. When that happens, a star too faint to see will flare up within hours, blazing about as bright as the North Star. A brand new light blooming in the crown where moments before there was nothing. It will hang there for a few nights, then quickly fade back into the black. And this is the maddening part. The blaze star has done this before, roughly every 80 years, and by that clock, it's due right now. Researchers have circled date after date on the calendar, and the star has blown straight past every one of them, refusing to perform on cue. It's overdue. It's being watched around the clock, and it could ignite at absolutely any moment. So before we walk the rest of the timeline, do this. Step outside on the next clear night, find that faint crown of stars, and take a look. You might just catch a star being born. Our first firm date on the calendar arrives on August 2nd, 2027, and it turns day into night. It sounds at first like an ordinary solar eclipse, the moon sliding in front of the sun for a couple of minutes while everyone slips on their glasses. This is not that. On that day, the machinery of the solar system lines up with eerie, almost unfair precision. The moon will be near its closest point to Earth, so it looms unusually large. The Earth, at the same moment, will be near its farthest point from the sun, so our star looks unusually small. A big moon, a small sun, and the shadow that falls will be one of the longest of the entire century. Totality will last an astonishing 6 minutes and 23 seconds. And no other eclipse this century before or after will beat it. A band of true darkness about 160 miles wide will race across the planet, sweeping from southern Spain across North Africa and the Middle East, plunging the temples of Luxor into a false midnight and passing directly over the deserts of Arabia. Along that path, in the middle of the day, the stars will come out. Birds will fall silent. The temperature will drop like a stone. For those few minutes, tens of millions of people will stand under a black hole where the sun should be and feel in their bones that something has gone deeply wrong with the world. Then the light returns. An eclipse is perfectly safe and perfectly predictable, timed to the second. But what comes next is a great deal harder to predict. April 13th, 2029. An asteroid named Apophis comes to visit. This chunk of rock and metal, roughly 1,100 feet across, is about the size of a large skyscraper laid on its side, and it carries the name of the Egyptian god of chaos for good reason. When astronomers first spotted it, they ran the numbers, went pale, and handed it the highest threat rating any asteroid has ever received. For a while, a real collision with Earth looked possible. Sharper measurements pulled us back from that edge. There will be no impact, not in 2029 and not for at least 100 years after. But the flyby itself is going to be jaw-dropping. Apophis will pass just 20,000 miles above the surface of Earth. That is closer than many of the satellites beaming this very video to you. It's more than 10 times closer than the Moon. A mountain of space rock will thread the needle right through our ring of satellites. And you will be able to see it from Europe, Africa, and Asia with no telescope at all. A bright point of light will slide silently across the night sky, a moving star that is really a killer asteroid on a near miss. As it whips past, Earth's gravity will grab it and squeeze, tugging harder on the near side than the far side, hard enough to trigger landslides and quakes across its surface and permanently bend its orbit. We will reach out with an invisible hand and reshape another world live in a single night. But an object like Apophis survives that encounter because it stays at a distance. Something else is not going to be so lucky. December 2032. This time, the target is the Moon. For months, astronomers tracked this smaller, stony asteroid around 200 feet wide and watched its path curve uncomfortably close to our companion. At one point, the odds of it actually striking the Moon were rated at a few percent, and in the strange math of orbital mechanics, that is not small at all. That is a genuine edge-of-your-seat threat. A direct hit would be staggering. The Moon has almost no atmosphere to burn a rock up or slow it down, so this one would come straight in at full speed and slam into the surface with the force of a large nuclear weapon, hundreds of times more powerful than the bomb that leveled Hiroshima. It would carve a fresh crater into the face we have stared at for all of human history and blast a plume of debris into space that could threaten the satellites we now fly around the Moon. And the wildest part of all, we would see the flash from Earth in real time with our own eyes. As the measurements sharpened, the odds shifted, and the likeliest outcome is now a near miss, the rock sailing past by a cosmic hair. But it is a reminder of something we prefer to forget. The sky is not just a light show, it is a shooting gallery, and every so often, we are downrange. Now, if all of this is starting to feel like a run of near misses and lucky escapes, hold on, because the timeline is about to change character completely. The early events are the universe throwing punches and pulling them at the last second. What comes next is different. These are not threats. They are once-in-many-lifetime spectacles. Cosmic events so rare and so beautiful that people will travel across the planet just to stand beneath them. And the next one belongs to America. August 12, 2045. The Great American Eclipse. Less than 2 decades after the old world goes dark, it is North America's turn, and this one is built for the record books. The Moon's shadow will make landfall on the coast of California and carve a diagonal path clear across the country, through the heartland all the way to Florida, before racing out over the Atlantic. For a stretch of the United States, this will be the longest total eclipse in the nation's history, with parts of Florida bathed in darkness for around 6 minutes. A single coast-to-coast sweep will hand totality to a huge slice of the country in one afternoon. Whole cities will step outside at midday, watch their shadows sharpen and their world dim to twilight, and fall silent together as the sun disappears. It is the kind of event that stops a nation in its tracks, and unlike an asteroid, it comes with a guarantee. It will happen exactly on schedule, down to the second. But not everything in the sky keeps such polite appointments, and the next visitor only comes once in a very long while. August 2050. Look up on the right night, and you will find a fierce red star blazing where none belongs. So bright it seems like a warning, like something in deep space has caught fire and is heading our way. Relax, it's only Mars dropping in for the closest visit of the century. Normally, the red planet keeps its distance, hanging tens of millions of miles away, often more. but every so often the orbits conspire. In 2050, Mars reaches its closest point to the Sun at the very moment Earth swings directly between them, and the gap between our two worlds collapses to just under 35 million miles. In cosmic terms, that is practically arm's length, one of the closest approaches since the record-breaking pass of the early 2000s. For weeks, Mars will burn as one of the brightest objects in the entire night sky, a hard, unblinking red eye staring back at us. And you'll not need some billion-dollar observatory to enjoy it. Through the cheapest backyard telescope, Mars will swell from a dim red dot into a real, living world, complete with its bright polar ice caps and the great dust storms rolling across its face. For a little while, our neighbor stops being a distant rumor and becomes a place you can almost reach out and touch. Then it drifts away again. But 11 years later, the sky delivers a comeback humanity has been waiting on for 3/4 of a century. July 2061. After a journey lasting a human lifetime, Halley's Comet comes home. This is the most famous comet in all of history, and not because of its size, but because of what it taught us. For most of the human story, comets were terrors, blazing omens that appeared from nowhere and sent crowds into the streets in a panic, certain the world was ending. Then a man named Edmund Halley did something revolutionary. He did the math. He proved these ghostly visitors were not random messengers of doom, but a single object, the same icy rock returning again and again on a strict schedule, every 76 years, chained to the sun by gravity. With nothing but a pencil, he tamed the sky. Halley's Comet is the only one bright enough that one person can hope to see it twice in a lifetime. Its last visit back in 1986 was a letdown. Earth and the comet were stranded on opposite sides of the sun, and most people who rushed out with new binoculars saw little more than a faint gray smudge. In 2061, the universe paces back. This time, we will be on the same side of the sun, perfectly placed, and Halley will unfurl its magnificent glowing tail across the sky. That tail, by the way, is the comet slowly boiling alive, a 9-mile mountain of dirty ice roasting in the sunlight and shedding millions of tons of itself into space. It will blaze past, dive back into the deep, and vanish for another lifetime. And once it's gone, the sky trades beauty for raw violence. 2083, a brand new star appears out of nowhere, and within days it becomes one of the brightest points in the entire night sky, outshining almost everything around it, bright enough to throw faint shadows on the ground. For weeks, it burns there, rewriting a familiar constellation. You might think you're watching a supernova, the death of a single giant star, but this is something far rarer. This is two stars dying as one. Deep in a system called V Sagittae, two stars are locked in a slow, doomed embrace. A dead, super-dense white dwarf is tearing plasma off its living companion, and with every passing year, the two are spiraling closer together, losing the fight against gravity. Astronomers who model this pair predict that around 2083, give or take, the distance between them finally drops to zero. When it does, the white dwarf plunges straight into the heart of its companion. It's not a graze. It's a merger, a head-on fusion of two suns that unleashes a titanic thermonuclear blast. For a while, the wreckage will shine as one of the most brilliant stars in our sky, a beacon marking the exact spot where two stars became one. Then slowly, the glow fades, leaving a single star where there used to be a pair. It will be the most violent event of the century that we can watch with nothing but our own eyes. And after all that fury, the sky's next trick is pure silent illusion. March 2092. Point a telescope at Jupiter and you will see the impossible. The giant planet's 4 great moons, the same 4 Galileo spotted 4 centuries ago, will simply vanish, melting together into a single gleaming point of light. After a real stellar collision, you would be forgiven for bracing another catastrophe. This time, there is none. This is the universe showing off its geometry. Io, Europa, Ganymede, and Callisto all circle Jupiter on nearly the same flat plane. In 2092, Earth passes exactly through that plane, so we see their orbits edge on, like looking at a spinning record from the side. In that rare alignment, the moons line up and begin to hide one another. Some slip in front of Jupiter and blend into its swirling clouds. Others slide into the planet's enormous shadow and blink out entirely. Better still, the moons begin to eclipse each other, giant Ganymede throwing its shadow across the ice of Europa, snuffing out its light for the watchers back on Earth. For a couple of hours, the most famous moons in astronomy perform a vanishing act, folding into one bright dot before drifting apart and returning to normal, as if nothing happened. It's a reminder that not every rare event is a disaster. Some are just the clockwork of the heavens, briefly lining up in our favor. But one final event remains on this list, and it is the only one that refuses to be scheduled at all. Look up at the constellation Orion and find the bright reddish star making his shoulder. That is Betelgeuse, a red supergiant so enormous that if you dropped it where our sun sits, it would swallow the Earth, Mars, and everything in between. And Betelgeuse is dying. The star is running out of fuel, and when something this massive dies, it does not go quietly. It detonates as a supernova, one of the most violent explosions of the cosmos. When Betelgeuse blows, the flash will be so bright it shows up in broad daylight for weeks, throwing shadows at night. Briefly, the most dazzling star our species has ever seen. Then, over months, the glow fades, and Orion is left with a missing shoulder, a gap in a pattern humans have traced for all of recorded history. And the haunting part is this: no one can tell you when. It could be 100,000 years from now, or the light could already be racing across the space toward us, and it might arrive tonight, or next year, or the day you happen to look up. Betelgeuse may have already exploded centuries ago, and we're simply still waiting for the news to reach us. It is the one cosmic event we cannot put on a calendar, the universe reminding us that for all our math, all our certainty, some things still arrive entirely on their own terms. So there it is, a timeline written across the rest of your life and beyond. A sun switched off over the desert, an asteroid threatening our satellites, a rock aimed at the moon, Mars burning red, a comet coming home, two stars dying as one, and a star that could vanish from Orion at any moment. The sky above you is not a still finished thing. It's alive and it's moving, a slow machine of unimaginable power grinding through events we get to witness only because we happen to be here at the right time. All it asks is that we remember to look up, because the show has already started, and the next act is closer than you think. And if watching the universe reveal its rarest secrets does something to you, there is one place it guards more fiercely than any other, a place that swallows even light and refuses to let its answer escape. We went as far into it as anyone can in our video on what's inside a black hole. Watch that one next. Stay insanely curious.